So this is the question that I've received from one of my online classes. This is question 4.4, number 16, online number 6, number 16 in the book. If you look in section 4.4, it'd be like number 16 in the book and number 6 online. So this is your online homework number 6. Before I even start on this problem, the first thing I would do is find the total for this group right here. I don't even know what we're doing, but usually that's what you're going to have to do first. So take this and add it all up. You're talking about 38 plus 8 is 46, and 46 and 46 is 92. Plus the 2 is 94, plus 7 is 101. So it looks like 101 is our total for this group. Let's check it with our handy dandy calculator and see what we get. Just to make sure that I can add work decent. That's going to be 10 plus 38 plus 46 plus 7. It's a miracle, 101. Alright, so our first one, our first problem, A, says 4 of the test subjects are randomly selected with replacement. That means we're going to use our exponents, because when you do your with replacement, the multiplicative law, that's when you use your exponents. With a true negative result. So that means this guy right here. True negative result. So that'd be 38. So 38 over 101 raised to the 4th power, because it's saying that 4 test subjects. So there's your exponent as 4. So take our handy dandy calculator and we get 38 divided by 101 is equal to, and we're going to raise that to the 4th power, and I get 0.02. So the answer to A is 0.02, and round according to whatever the directions say. Okay? And ours says round to 3 decimal places. So let me pull this back up. 0.020. So A is 0.020. Now, I'm going to go to a white screen with the next problem. Well, we can use this right here. Oops. That problem was 37 over 101 raised to the 4th power. Now, that's A. B says the same thing, probability of a negative test result, or a true negative, whatever, without replacement. Now, without replacement is when you start deducting by 1 on each calculation. So, 37 over 101 would be our first draw, times, well, we draw the name out of the hat, put it in our pocket. And how many does that leave in the hat? Well, with the true negative, leaves 36. And with the names in the hat, it'd be 100. And we draw that one. Draw a name out of the hat, put it in our pocket. That leaves 35 over 100. Draw a name, 99. And then the last one, draw a name, you have 34 out of, how many is left in half? 98. And we take our handy dandy calculator and we calculate that. And I use parentheses, so that'd be parentheses 37 divided by 101, close parentheses, times open parentheses 36 divided by 100, times, close parentheses, times open parentheses 35 divided by 99, close parentheses, times 34 divided by 98, close parentheses, and equals. I get 0.016. 0.016. Now you can see these are similar. This one comes out to 0.020. And technically, if you ran into the 100th place, this one would be 0.02. Now, one of the things I tell my students, and this is kind of like an undocumented rule, usually when you're talking about 3 digits, if you have 3 digits over 3 digits, chances are it's not going to make a difference whether you use with replacement or without replacement. Let me show you what I'm talking about. If, let's say I'm doing the first 3 draws, or what is the probability of all 3 being, negative test result. And my numbers are not 101, 37 over 101. It's more like 397 over 1036. And I'm going to raise that to the 3rd power. Okay? And we're going to get a number. So pull up our handy dandy calculator and we get 397 divided by 1036 equals raised to the 3rd power, and we get 0.05627. 0.0, I can't remember, 0.5627. Okay, everybody with me? Now let's do it, that's with replacement. But notice, you've got 3 digits over 3 digits, more than 3 digits. So you're talking about some big numbers here. Probability of 3 negative test results. And this is without replacement. That's where you put the one you drew, put it in the pocket. And that leaves -1 amount over -1 amount. So that would be 397 over 1036 times 396 over 1035, 395 over 1034. And what you're going to see is you're not going to see much of a difference between these 2 answers because these numbers are so big. So take your handy dandy calculator and we're going to clear it, and we're going to say 397 divided by 1036 times 396 divided by, sorry about that, divided by 1035 times 395 divided by 1034. And that's going to be equal to 0.05601. 0.05601. 0.05601. And I think the directions told you to round to 3 digits. And what do you notice? That there's no difference between the two answers. So if you are dealing with 3 digits over 4 digits, or I would say anywhere from the 200s over the 300s or something like that, you're not going to see much of a difference between the two answers, whether you do it with replacement, meaning the exponent, or without replacement, meaning the deducting 1 from each of the numerator and the denominator. So I hope this helps.